Hello and welcome to our lab on architecture and networks. Today is lab 4 on logic design. This is the outline of our experiment today. We will concentrate into truth table, logic equation, kernel maps, weights, and optimization. If you look into lab 4 no solutions document, you can find all the exercise we have in our lab today. I will work with this exercise on my slide. So we will go into first exercise about truth tables. This is the question for exercise 1. We consider a logic function with 4 inputs A, B, C, and D, and it will generate one output F. The function F will be defined as follows. F is true if C is true, and F is true if A is true and D is not true, and it is true also if B and D are true and A and C are not true. And the final condition for F to make it true is F is true if A and C are true and B is not true. And the question is, what is the truth table for that function? We will try to make a truth table. You know that we have 4 inputs A, B, C, D. So in total we have 16 situations for A, B, C, D as input. As 0, 0, 0, 0 for A, B, C, D, and then A will be 0, B will be 0, C will be 0, and D will be 1, or A, B, C, D equal 0, 0, 0, 1, and then the value change to 0, 0, 1, 0, and then 0, 0, 1, 1. If we gradually increase the value of inputs A, B, C, D, we will gradually increase the value like this, and to the end we will have A, B, C, D equal 1, 1, 1, 0, and then 1, 1, 1, 1. These are all the 16 input situations for the input A, B, C, D. Now we will need to find the output F for each of these inputs. At first we know that F is true if C is true. So we try to find all the value, all the inputs situation, all the input groups that we have C is true inside. So it is marked here in red. You can see we have 8 location here marked in red. So we will fill into the output F of this location by 1, or F is true. So here we have F is true in this input. The second condition is F is true when A is true and D is not true. Now we will look into all the input values in which A is 1 and D is 0. So you know all the input value for A equal 1 will be from here down here. So we will search for all the value of D equal 0 from here down here, and you can see 1, 2, 3, and 4 location that D is 0, and we will need to fill 1 into this place. So F here will be 1. Here it is 1 already, so we don't need to fill it. Here we fill by 1, and here it is already 1 given by this condition. The third condition is F is true when B and D are true, or B and D equal 1, and A and C are not true. So if B, D equal 1 and A, C equal 0, the output will be 1. So we search for For those value, we can see that A is 0, B is 1, C is 0, and D is 1. So we have only one line here, A, B, C, D here by this value, and so at this place we fill it by 1. The next condition is A and C are true and B is not true. If we look into this, we can see that C is true, make F is true. So here A and C are true, means that if C are true also, so all the place in which C is true, the output for that are already filled by 1, so no more change with this condition. The remaining place here will be replaced by 0. So now here, if we look into this, we can have the truth table for the f function with this condition. Now we go to exercise 2 about logic equation. The question for exercise 2 is, what is the logic equation for logic function f in exercise 1? So we will start with the condition that make f true. From that condition, from those conditions, we will make the function f. So f is true when c is true. It means that c equal 1, make f equal 1. So f will equal c for the first condition. The second condition is f is true when a is true and d is not true. This means that if a is 1 and d is 0, it will make f true, and so our logic equation change to f equals c for the first condition, or a and not d, so that when a is 1 and d is 0, it will make this part of the equation be 1. The third condition is f is true when b and d are true and a and c are not true. This means that b and d will be 1, a and c will be 0, making f is true. And so the third condition add one more part into our logic equation, that is a bar and b and c bar and d, or not a and b and not c and d, and so our f function or f logic equation change into f equals c, or a and not d, or a and not a and b and not c and d. And the last condition is f is true when a and c are true and b is not true, which means that a and c will be 1 and b is 0, making f is true. So it adds one more part, that is a and not b and c. So finally we have the logic equation f for exercise 1, that is f equal c and a and not f equals c, or a and not d, or not a and b and not c and d, or a and not b and c. The third exercise aims to kernel maps, and the question is, what is the kernel map equivalent to the truth table and logic function seen in previous exercise? And so we will start with our truth table that we already made from the exercise 1. We know that we have 4 inputs, A, B, C and D, with one output f, and here are the values or the outputs of f depends on the input value of a, b, c, and d. Now we will make the kernel map. We know that we have 4 inputs, and so we will divide the input into 2 groups, AB and CD. AB here will be in the horizontal axis, and CD is in vertical axis. For 2 input value AB, we have 4 cases of 0, 0, 0, 1, 1, 0, and 1, 1. We know that for the adjacent column or adjacent lines, the value of inputs should have only 1 bit difference, and so we arrange our input value of AB by 0, 0, and then 0, 1, and if we change for 1 bit, we change this bit with 0, making the input change to 1, 1, and then we change the remaining bit 1 here, making it 1, 0. Similarly, with the input CD, we will have 4 lines 0, 0, 0, 1, 1, 1, and 1, 0. The next step is we look into the truth table and we take the value, output value, and we fill into each element of this table. So for the input value of AB 0, 0, CD of 0, 0, which means that input A, B, C, D are 0, 0, 0, 0, here 0, 0, 0, 0. The output F is 0, and so we take this value and we fill it here. The next one, A, B, C, D is 0, 0, 0, 1, and the output is 0. So here 0, 0, 0, 1, the output is 0. Similarly, we will fill all 16 elements of this table. We just look into the 0 value now. So the output for 0 are here and here, which is AB is 0, 1, and CD is 0, 0. So AB 0, 1, CD 0, 0. So we have this 0 value. The fourth one, the fourth output of 0 here for AB 1, 0, CD 0, 1. So here 1, 0, 0, 1, this element, and we fill it by 0, and the one more output equal to 0 occur here when AB is 1, 1, and CD is 0, 1, and so AB is 1, 1 in this column, CD is 0, 1, 0, 1 in this line. So this element of the table will be filled by 0. The other elements of this table will be 1, and so we have the kernel map similar to this. Now we go to exercise 4, which aims to get in our lab today. The question is, what is the logic gate implementation equivalent to logic function seen in previous exercise? We will go with our function that is given in exercise 2. F equal C or A and not D, or not A and B and not C and D, or A and not B and C. We know that in this equation we will need the value of AND logic first before we all of them together. So we will need the input, we will need to calculate C, or it is just the input, A and not D, not A and B and not C and D, and then we will need the result of A and not B and C. So we have here the input C, the signal for the input C, and then we need the another result for A and not D. So we will input AND logic here, in which the input value of D will be inverted at first. So here at this end of the logic, we will have A and not D. The next AND calculation will be this one, not A and B and not C and D, which is a little bit more complicated with 4 input values, with 4 input, and so we will separate them into 2 groups of not A and B, and then not C and D, and then we make a final AND of those together. We will have this value. So here we have not A and B, and at the end of this AND logic we will have not A and B, and here not C and D, and we have the output here of not C and D. We AND those 2 values together, and at the end here we will have not A and B and not C and D. Well, the final AND value we need to calculate is A and not B and C. So here we input A and not B here together with an AND. So we have A and not B appear here, and the input value for C, and we AND these 2 together, we will have A and not B and C. So here we have 4 signal, 4 output, 4 regions available here for C, A and not D, not A and B and not C and D, and this one A and not B and C. Now we need to all of them together. So we will make an OR here and an OR here to make the red and blue part, and the purple and orange part. So here after this OR logic, we will have the value of C, OR, A and not D, and one more OR logic here, which will generate the value for not A and B and not C and D, or A and not B and C. And of course finally we need to OR these 2 together to have the final F value. Now we move to exercise 5, optimization. The question is, considering the truth table and the color map seen in previous exercise, would it be possible to simplify the logic equation in exercise 2? If the answer is yes, show the equivalent truth table and color map, and if the answer is yes, show the equivalent logic gate implementation. And of course we know that if the answer is yes, of course the equivalent truth table and color map will not be changed, so we will not go into detail of this part. Instead we will go into the detail of equivalent logic equation, the optimized logic equation for exercise 2 together with the logic gate implementation. So now here we come back with our color map with 4 input values of A, B and C, D here. We know that in order to implement the function with color maps, we will group all the input which generate the value of 1 in adjacent elements together. So here you can see that we have a big group of output value 1 available here. If we look into this part, we can see that regardless the change of AB from here to here, so A and B can be either 0 or 1. It didn't make change to the output, So the value will be relies on C and D. The output value will relies on C and D, and if we look into this part, we can see that C keeps the same, but D can be changed either 1 or 0. So we know that for this part of kernel maps, the output value relies on value of C, which is 1 only, and so here F equals C. And for another part of kernel map, here the value of 1 here in adjacent element, we can see that this output doesn't rely on B value, but it relies on A value, A input value, and it relies on C, D input value, which is 0, 0, and so we can have this part as A and not C and not D. So here we add one more part of A and not C and not D here. We can see that we have one more value of 1 available here. So we take these two elements together, and we can see that for this output, the output value didn't rely on C, because C can either be 0 or 1. Instead, these outputs relies on AB, which is 0, 1, and D, which is 1, and so this one will be not A and B and D, not A and B and D, and so here we have no more value of 1 that is not yet processed in the kernel map. And here is the final logic function for F. F equal C or A and not C and not D, or not A and B and D. Next, we will generate the logic gates for this function. Similar with the exercise 4, we have 3 parts all together here, and we will need the output of the AND logic here and here in blue and purple before we all own together. So here we have the input value for C, we have input value for A, and then we have input value for C and D. We make inversion for C and D, and we all them together. We will have not C or not D, not C and not D available here. And so we make one more AND here. We will have the value of A and not C and not D. Now we will make the output for this AND in purple. We have A, not A, and so here we have A, and we invert it, we will have not A available here. We will need B and D, so here we input B and D here together with an AND, and so B and D is the input for this AND. The output of this AND will be B and D, and we AND these two together. We will have not A and B and D available here. So now we have C here, A and not C and not D here, not A and B and D here, and we need to all of them together. So we will need we will add an OR here, and the output here will be C or A and not C and not D, and we all make the final OR here together with this to make C or A and not C and not D to all together with not A and B and D of this signal, and the output will be the function F. And now we go to the end of our labs on architecture and networks. If you have any question, please send me by your email. Thank you very much.